Okay, so this video here is going to go over the particular questions or examples of questions on the final exam that come from Chapter 4 of the textbook. Okay, so here we are in Chapter 4. And by the way, you may wonder why I'm showing you this particular screen here. The big reason why I'm showing this is because this is a behind-the-scenes view here. Kind of how I see things, you know. And it's important because each one of these questions, as you're looking here, has the objective up here. And it kind of shows you exactly what this particular problem is assessing on your ability here. So as you can see there, we're talking about using the negative exponent rule here. All right. So let's just think about what is the negative exponent rule. Remember, that one was a to the n, negative n. Oops, let's bring that down. Remember, the negative exponent rule was a to the negative n is equal to 1 over a to the n, right? So basically, a base to a negative exponent is the reciprocal of that base, right? And another way to say it is when you see a negative exponent, what you do is you move the base to the opposite side of the fraction bar and keep the base, but you turn that exponent, for example, here in positive. All right. So here we have, so it's asking us to write the expression and then with only positive exponents, right? And let's just zoom out here. All right, so it was going to want an integer or a fraction. All right, so we're not asking for a decimal, and the final exam will clearly point out that we're looking for an integer or a fraction, not a decimal. So sometimes students will put this in their calculator, then they'll write out the decimal approximation. Remember, those decimals are just approximations. What we really want to do in math is show an exact answer, which is best represented by a fraction. Okay. So here we have 3 to the negative 4. Okay. And so what we do is move that base to the opposite side of the fraction bar, and then take it to the positive version of that exponent there. In this particular question, that is acceptable to put 1 over 3 to the 4th. But, you know, you could go ahead and evaluate 3 to the 4th, which is 3 times 3 times 3 times 3. A very basic definition of a exponent, right? You multiply the base times itself, however many times is indicated in the exponent. So we're multiplying 3 times itself 4 times. So what that comes up to be is 1 over 81, because 3 times 3 is 9, times 3 is 27, times 3 is 81. Okay, so there we go. That's our first example there from Chapter 4. All right, so again, what we're doing here, look to our objective here. We're using power rules, all right, to kind of rewrite, well, not kind of, but we are going to rewrite these expressions. And when you rewrite it, you want to be sure to follow all the instructions that are asked in the particular question. So it does give you a really big hint here, the power rule. And then if you look at it, what we have here is a quotient, a quotient to a power, right? Okay. So remember the quotient rule here was a quotient to a power rule was a over b to the n is equal to a to the n over b to the n. So in other words, what we do when we have a rational expression here raised to a power, or a quotient to a power, what we do is apply the power to both the numerator and the denominator. Okay? All right. So in our particular, and then, all right, so look exactly what it says again. Type an integer or a fraction. And notice it doesn't specifically say write it using only positive exponents. So, like, as far as homework goes, notice how they have the answer there. They didn't write those numbers to the power. What they did was evaluate them. Okay. So what we have here is 2/5 to the third, and what we do, a quotient to a power, what we do is apply the exponent to both the numerator and the denominator. So we got, in the numerator, we got 2 to the third, and in the denominator, we've got 5 to the third, right? So 2 to the third is 8, right? And then 5 to the third is 125. So there is our result. Simplify. All right, so here's another one that you definitely don't want to miss here. And all we're trying to do here is combining like terms of a polynomial. So it's asking us to combine like terms. All right. So let's go ahead. Let's just write it out. 9a minus 2b minus 7a plus 18b. Okay. So like terms, remember, have the same variable involved in them. So basically 9a and 7a would go together, and negative 2b and 18b would go together here. So remember, same exponent, same variable. Those are like terms. All right, so I'm gonna write something here that you may, you don't necessarily have to do when you're showing work. But what I'm going to do here is just put the two terms that go together in parentheses, just emphasizing what we're doing here, right? We're putting the A's together and we're putting the B's together. So you don't have to include that step. You could probably do that in your head, basically. So 9a minus 7a is 2a, and negative 2b plus 18b is 16b, okay? So you do not want to miss this particular one here. You don't want to miss it. That's way too easy to miss. So be sure to get this one correct. All right. So what we have here is, look at our objective, multiply any combination of polynomials. Well, what the question is asking us to do here is find the product. So basically what we're doing is multiplying these two binomials here, 4c minus 3, the quantity 4c minus 3 times the quantity 5c plus 5. So let's write that. 4c minus 3 times 5c plus 5, okay? So when we're finding a product of two binomials, what we're actually doing here is referred to as FOIL, remember? FOIL. And remember, FOIL, the F in FOIL stands for first. The O in FOIL stands for outer. The I in FOIL stands for inner. And the L in FOIL stands for last. Okay? So I'm going to move the next step here down to a little bit to that position right there. All right, so, but basically, and then I'm going to do a couple of things here. I'm going to draw some arrows. I'm not a big fan of the drawing arrows when I foil, but if that helps, feel free to do that. And also in this next step, I'm going to write some things out that are not necessarily they're not necessary to show your work, but we're going to go backwards a little bit on this, and basically I'm going backwards by listing again the FOIL process. But we're just going to go backwards and then rethink what we did in chapter 4. By the way, foiling is essential to any of the other math classes that you will take. If you are not able to do FOIL properly, you're really going to run into a dead end in these other classes. So you really want to master this concept. And that's why it's included on the final exam. It's very critical. Okay. So first, well, all right, so to begin this thing off, we're going to consider the F in FOIL first. So drawing arrows here, we're basically going to multiply 4C times 5C. Okay, so what we have here, and I said this next one here is including a step that is not necessary. And if you remember, when we talked about this, I suggested, as well as the textbook suggested, that when you're foiling, you do as much of it mentally as possible. Because I showed you a really long example of breaking it down specifically, and it can be a little bit overwhelming. And then, as I said, when you write too much in some of these cases, it does kind of foster mistakes. But I'm going to go backwards and break everything down individually here. So what we have there is 4C times 5C. That's our first. Next, we will do the outer, which would be 4C times 5, right? These are the first in the binomials, and then 4C and 5 are the outer, right? So they're going to take a positive sign. So what we have is 4C times 5. Okay. Then we're going to do the I in FOIL, which is inner. So that would be negative 3 times 5C. So it's going to take a negative sign because I got a negative and a positive. So I've got 3 times 5C. Okay. And then we're going to do the L in FOIL, which is the last, which would be negative 3 times 5. The last terms in the two binomials. So these things are going to get a negative and a positive, so they're going to take a negative sign. So I've got 3 times 5. All right. So I just included that step there just to reiterate what's happening with the FOIL process. So our next step would be to do this. So 4C times 5C is 20C squared. All right. A lot of times students will say 4C times 5C is 20C. It's remember that squared part, okay? Because we're using the product rule here. Basically, C to the first times C to the first means we add the exponents, so we end up with C squared, right? So we got 20C squared. Now 4C times 5 is 20c, all right? And now negative 3 times 5c is negative 15c. And then negative 3 times 5 here is negative 15, right? So a lot of times I'll joke with everyone and say, all right, we're done, right? Well, actually, we're not done. Because remember, when you FOIL, it's very important that at the very end, you combine your like terms. You combine your inner and outer here. It's not complete until you've combined like terms and simplified. So like if we were to go over here, notice that it clearly says simplify the answer. So we've got to combine our like terms. So our end result would be 20c squared plus 5c minus 15. So now we are done. We've multiplied those two binomials and we've used our FOIL process. All right, so there we go. Those are the examples of questions that'll be on the final exam that come from Chapter 4 of the textbook.